Alexander, and today I'm going to talk to you about IB subtopic 5.4, the part of it where we're doing finding the angles between two lines or between a line and a plane. In the first part here, I simply want to find, I want to mark the angle that is given in the description. Now in part A here it says let's mark the angle that the face ADHE makes with the line EG. So the first thing I want to do is make that line EG. So I'm going to make 2 points and just connect them as best as I can. And this is a multi-step process. The first step is to connect those points, and then it's to drop the perpendicular. We're trying to make a right triangle. So if I drop this perpendicular right here, I can make a right triangle, which is the right triangle that I've created. Now, I haven't answered the question yet. I'm supposed to mark the angle that the face ADHE makes with the line EG. So it's either this angle or this one, but the base is ADHE on the bottom, so it's this angle that I'm marking right here. Part B, I'm supposed to mark the angle that the face ADHE, again the bottom, makes with the line EC. So if I connect E and C to the best of my ability, make that line as straight as I can, and then drop the perpendicular. The perpendicular in this case is going to be from C to D right here, and then I can complete my right triangle. There's my right angle. I've got two angles in that triangle. The one that I want is the one that's connected to base ADHE, so I'm looking for this angle right here. In part C, I'm looking for the angle that the face EFGH, the one on the side, makes with the line CE. So let's start with CE again. I'm going to connect those two. And this time, the perpendicular I want to make is the one that goes across this base here. So this is a little bit harder to see, but since I'm talking about this side EFGH, the perpendicular that I want to create is actually from right here, E to G. And so it's hard to see, but this is actually a right triangle right here, and the angle that I want is right here. So that was a tougher one right there. Sorry, I kind of extended that. That should be the right triangle right there. Part D, I want to find the angle between lines CE and CF. Now these are the easy ones when you're just dealing with two lines, because all we have to do is draw those two lines, and we don't even really need to worry about a right triangle. All I need to do is draw the angle between them. Now I actually did draw a right triangle. It's right here, but I didn't need to worry about that. Whenever you're dealing with two line segments, it's just the angle wherever they intersect. So that's drawing pictures, but we also have to do some math. Like in question 4 here. So we have a cuboid, which is just a rectangular prism. Cuboid is IB speak for rectangular prism. And what we're trying to do here is we are told that the length AD is 10, EA is 3, and DC is 4. And we are trying to find the length of AC. So AC is this diagonal across the bottom here. It's right there. And hopefully you can see that there's a right triangle from A to D to C. Triangle ADC is a right triangle, and I'm just trying to find the hypotenuse of that. And so what I need to do is simply do the square root of 10 squared plus 4 squared. And that's 100 plus 16, so it's just 116, which to three significant figures is 10.8 centimeters. In part 2, we're supposed to calculate the angle that AG makes with the face ABCD. So ABCD is right here. I'm actually going to try and draw this one. I've got A, I've got G. I'm going to drop the perpendicular. And so I've got this right triangle here. And I'm trying to find this angle right here. So if I draw the right triangle off to the side right here, I've got my A, my G, and my C. I'm trying to find this angle. I happen to know that GC is 3, and I just found AC to be 116. So to find the angle, from that angle, the 3 is the opposite side, the 116 is the adjacent side, so I'm using the tangent to get angle GAC. And I know that's 3 over square root of 116. So angle GAC is simply the tangent inverse of 3 over the square root of 116. And when I type that in my calculator, tangent inverse of 3 divided by the square root of 116, then I get an angle to 3 significant figures, which is 15.6 degrees for A2 there. All right, part B, which I'm going to do right here, calculate the length of AF. Well, that's just the hypotenuse of this other right triangle here. So from F to B, that's 3. From A to B, that's 4. So I'm just looking for the square root of 3 squared plus 4 squared. That's 9 plus 16 is 25. The square root of 25 is 5 centimeters. That's the length of AF. Part 2 says, find the angle that AEFB makes with the line AG. So now, I'm dealing with this other right triangle right here, and I'm trying to find the angle that AEFB makes with AG. So it looks like it's this angle right here. I'm just going to try and redraw that right triangle really quick here. So I've got my A over here, I've got my F, and I've got my G. And I know that from A to F, that's what I just found. A to F is 5. And from F to G, that's 10. So I've got my, from the angle that I'm trying to find, I've got my opposite side and my adjacent side. So I'm going to do the tangent of angle GAF is opposite, which is 10, over adjacent, which is 5. So angle GAF should just be the tangent inverse of 10 over 5, which is just 2. And when I do that, angle GAF is just about 63.4 degrees, and that's to 3 significant figures. Alright, I've got time to do one more here, and so I'm going to jump to question 8, which is an IB problem, actually. Well, it's the start of a paper 2 question. It's just one part of the paper 2 question. And it says, the Great Pyramid of Cheops in Egypt is a square-based pyramid. If this is a square, that means that's congruent to that, it's congruent to that, it's congruent to that. They're all 230.4 meters. The base of the pyramid is a square with length 230.4 meters and vertical height of 146.5 meters. It's got a vertex, and the center is O. M is the midpoint of BC. Show that the angle between VM, which is this line right here, show that the angle between VM and the base is 52 degrees to correct the 2 significant figures. So if I'm going to make this right triangle, the right triangle I want to make is this one right here. Now I'm just going to draw that right triangle off to the side so I can see it a little bit better. I've got my O, I've got my V, I've got my M. I've got a right triangle. I know this is 146.5. We actually know the length of OM as well. And the length of OM is simply half of 230.4. And half of 230.4 is just 115.2 centimeters. Or sorry, meters, not centimeters. These are meters. And the angle I'm trying to find is the angle between that line and the base. So it's this one on the bottom. Now from that angle, I'm trying to find the opposite and the adjacent. That's the tangent. So the tangent of angle VMO is 146.5 over 115.2. So then angle VMO is the tangent inverse of 146.5 divided by 115.2. And when I type that in my calculator, I'm going to actually show you what I get this time. It's this. It's 151.82. Now to 3 significant figures, that's 51.8. But they like to throw you curveballs on paper too. And this is one of the curveballs they're throwing. They're saying round it to 2 significant figures. And to 2 significant figures, that indeed is 52 degrees. That's exactly what I'm trying to do. What I'm trying to find. So there, I showed it. Bam, got it. Okay, that's it. Thank you for watching. On our next video, we'll deal with finding the surface area and volume of these 3-dimensional figures. Thank you.